Hello dear students, welcome to my channel. So today we'll begin with the problems on midpoint theorem, that is exercise 12a. Alright, so the first question says, in a triangle ABC, M is the midpoint of AB, a straight line through M and parallel to BC cuts AC in N. Find the lengths of AN and MN if BC is equals to 7 centimeter and AC is equals to 5 centimeter. Now, whatever is given out here, we'll draw the same in a diagram. Alright, so there's a triangle ABC. So take triangle ABC. Alright, so triangle ABC is taken. Now it is said that M is the midpoint of AB. So this is my AB. So take the midpoint to be M. Alright, okay, so the next thing is a straight line through M and parallel to BC. Okay, so a straight line you have to take from M which is parallel to BC. So from M I have taken a straight line which is parallel to BC. Alright, and this extended line cuts this line, that is AC, in N. That means this straight line cuts this AC at point N. Alright, so everything is noted out here. Alright, now we need to calculate the length of AN and MN if BC is equals to BC is given to be 7 centimeter and AC, this full length, is given to be 5 centimeter. Alright, so the triangle shows the given condition. Okay, so this triangle shows whatever is given in the question. Alright, now let us see what is written here. Since M is the midpoint of AB, alright, so since M is the midpoint of AB and MN is parallel to BC, that means we can make use of what? We can make use of converse of midpoint theorem. So converse of midpoint theorem says, if you take the midpoint of any one side, alright, and from there if you draw a parallel line, then this parallel line cuts the third side into equal halves. That is, this point will be the midpoint of AC. Right, so hence N is the midpoint of AC using converse of midpoint theorem. So therefore we can say that this MN is half of BC, isn't it? Right, so MN will be half of BC, and how much is BC? BC is 7 centimeter. So that's why half of 7 is how much? 3.5. So my value for MN is 3.5 centimeter. So this is going to be 3.5 centimeter. All right, and we need to calculate what? We need to calculate AN. Now we know that since N is the midpoint of AC, AN will be half of AC, isn't it? So that's why AN will be half of AC, which is half of 5, which is 2.5 centimeter. Alright, so you may pause the video to note down. Okay, now let us see the next question. So question says, prove that the figure obtained by joining the midpoints of the adjacent sides of a rectangle is a rhombus. Alright, so we have to take a rectangle. Alright, so ABCD, this outer one is a rectangle out here. Alright, now you have to take midpoint of the adjacent sides. That means I have taken midpoint of all the sides here. Alright, so the midpoint of AB is given to be P, midpoint of BC is taken to be Q, midpoint of CD is taken to be R, and midpoint of AD or DA is taken to be S. Alright, so that's what is written out here. Now what we need to prove here is, now the figure obtained by joining the midpoints will be a rhombus. So when you join the midpoints, okay, so whatever figure you get, that has to be a rhombus. That's what we need to prove. Now what is rhombus? Now rhombus is a parallelogram. Alright, so that means the opposite pair of lines are parallel, and on top of that what happens is all the sides will be equal. Alright, so rhombus is a parallelogram in which all the sides are equal. Alright, so for help in this diagram we draw two diagonals, that is BC and AC. Alright, so I have drawn AC and BD diagonals. Alright, and since ABCD is a rectangle, the diagonals will also be equal to each other. Alright, so that's why BD is equals to AC, since diagonal of the rectangle are equal. Okay, now let us observe triangle ABD and BCD. All right, so where is ABD? So ABD means this triangle. All right, now if you see only this triangle, okay, so forget about this lower part. All right, so forget about this. So if we see only ABD, then this P and S are midpoints of AB and AD, isn't it? So that's why I can say this PS. All right, so the line segment joining the midpoints will be parallel to the third side, that is parallel to BD. All right, so that's why it is written PS is parallel to BD. All right, so this is for the triangle ABD. All right, so for triangle ABD, I see that PS is parallel to BD. Okay, now not only parallel, but this PS will be half of BD. All right, so that's why it's written PS will be half of BD. All right, okay, now let us see what is happening in triangle BCD. Now BCD means this triangle. All right, so this down, or the triangle which is lying to the down position of this earlier triangle. So here in triangle BCD, again Q and R are the midpoints of BC and CD, isn't it? So similarly we can say that this line segment QR will be parallel to BD, right, using midpoint theorem. All right, so QR is parallel to BD, so that's what is written here. All right, and not only parallel, but this QR will be half of BD, right? So that's what is written here. So QR is half of BD. All right, okay, so if I combine these two triangles, I can say this is parallel to this and this is again parallel to this. So that's what is written here. All right, and this is half of BD and this is also half of BD. So combining both, I am getting this. All right, or if I multiply both side by 2 here, all right, so if I multiply both side by 2, then I'll get 2 times PS, right, 2 times QR, and half into 2 becomes only BD. All right, so this means 2 times PS is equals to 2 times QR is equals to BD, and from here I can say that PS and QR both are parallel. All right, so see, my aim is to show that PQRS is a rhombus. All right, so what I have shown here is this and this are parallel, and we know that opposite pairs of lines are parallel in case of rhombus. All right, so we have successfully shown that PS and QR, they are parallel to each other. All right, okay, now similarly in the same way we can show that this PQ and SR, they are also parallel to each other. All right, so similarly we can show in the same way this happens. All right, okay, now let us combine 1 and 2. Okay, so from here we see that 2 times PS is equals to 2 times QR, and this is equals to BD, and where is BD? BD is the diagonal. All right, and from the second case we can see that 2 times PQ is equals to 2 times SR, which is equals to AC. And what is AC? AC is this one. Now we know that BD and AC both are equal, right, because they are diagonals. So that's why if BD and AC are equal, then all of them have to be equal to each other. That means PQ will be equals to QR, QR will be equals to RS, and RS will be equals to PS. That means all the sides are equal, right? So all the sides are equal, and these two pair of lines are parallel. So what is the meaning of this? This means that this figure, that is PQRS, is a rhombus. All right, so we have successfully proved this particular question. So you may pause the video to note down. Okay, now let's have a look at the third question. So question says D, E and F are the midpoints of sides AB, BC and CA of an isosceles triangle in which AB is equals to BC. All right, so there's a isosceles triangle ABC where AB and BC, they are equal to each other. All right, and it is given that D is the midpoint of AB, E is the midpoint of BC, and F is the midpoint of AC. All right, so that's what is given out here, and we need to prove that DEF, that is this triangle, that in this inner smaller triangle is also isosceles triangle. Alright, so let us begin. Now it is given that ABC is an isosceles triangle where AB is equals to AC, and we know that DE and F are midpoints of AB, BC and CA. Alright, now let us see what is happening here. Now since D is the midpoint, D and F are the midpoints, so I can say, or since D and E are the midpoints, so I can say DE will be parallel to AC and this DE will be half of AC, or in other words this AC will be double of DE, right? So that's why it is written 2 times DE. Double of DE will be AC. Alright, and similarly this E and F are the midpoints, so that's why this EF will be half of AB, isn't it? So that's why 2 times EF will be AB. Alright, now we know that AC and AB, they are equal, right? So since they are equal, then 2 times EF must be equals to 2 times DE, which means what? Which means DE must be equals to EF. Alright, so that's why since two sides of this inner triangle are equal, so this means that this triangle is also isosceles triangle. Alright, so you may pause the video to note down. Okay, now let's have a look at the fourth question. So question says the following figure, that means this figure shows a trapezium in which AB is parallel to DC, and we know that in a trapezium what happens is two sides will always be parallel, and here it is given that AB is parallel to DC, so AB and DC, they are parallel to each other. P is the midpoint of AD, so P is the midpoint of AD, and PR is parallel to AB, so PR means this line is parallel to AB. So these are the things which are given, so we need to prove that PR will be this much. So let us see how to prove this. Alright, so please make sure that you don't write 9 out here. Alright, so this is a printing mistake here. Okay, so here what I have done is I have joined B and D. Okay, so after joining B and D, we can see that there is a triangle ABD, isn't it? And in this triangle ABD, what is happening? This P is the midpoint of AD, right? So P is the midpoint of AD. So P is the midpoint of AD, and this line is parallel to AB, isn't it? That's what is given. So PR is parallel to AB means this PQ is also parallel to AB. So that's why using converse of midpoint theorem. See, here only one of the midpoint is given, and it is said that this is parallel to this side. So that's why using converse of midpoint theorem, I can say that Q is the midpoint of BD, isn't it? So that's what is written here. So from triangle ABD, P is the midpoint of AD and PR is parallel to AB, right? So that's why Q will be the midpoint of BD using converse of midpoint theorem. Alright, so similarly if I see here, if I see this triangle BCD, so this Q is the midpoint of BD and this QR is parallel to CD, isn't it? Now see, you know that AB and CD are parallel, so if this line is parallel to this, then this line is parallel to this as well. Alright, so that's why Q is the midpoint and QR is parallel to CD. So again using converse of midpoint theorem, so I can say that this R is the midpoint of BC. Alright, so that's what is written out here. So R is the midpoint of BC and PR is parallel to CD and CD is parallel to AB. So that's what is written out here. Alright, okay, so if this thing happens, like if P is the midpoint, Q is the midpoint and R is the midpoint, then I can say that this PQ is half of AB, or in other words I can say this AB will be double of PQ. So AB will be double of PQ. So let me call this as equation 1. Now in another triangle, we know that this QR is parallel to DC, right? So I can say this DC is double of QR, right? So DC or CD is double of QR. So let me call this as equation 2. So let me add 1 and 2. So after adding 1 and 2, what I see is 2PQ plus 2QR, where 2 is common. So if I take 2 common, then we have PQ plus QR out here. and in the right hand side we have AB plus CD, right? Now let us see what is PQ plus QR. So PQ plus QR gives me the whole line PR. All right, so instead of PQ plus QR I am writing PR, and this 2 goes to the denominator, becomes half. All right, so that's what we need to prove in this particular question. So you may pause the video to note down. Okay, let us have a similar question. Here also we have been given a trapezium where AB is parallel to DC, as we can clearly see from the figure. It is given that M and N are the midpoints of non-parallel sides AD and BC. So the midpoint of AD is given to be M and the midpoint of BC is given to be N. Alright, so we need to find MN if AB is equals to 11 centimeter and DC is equals to 8 centimeter. First let us have a look at this and we'll go to another one later. So before that we will draw a diagonal AC as we did in the earlier question. Alright, so AC is the diagonal and O is the point of intersection of MN and AC. Okay, now in the first question it is given that AB is 11 centimeter and DC is 8 centimeter, right? So let us see where is AB. So AB is given to be 11 centimeter, right? And DC means this is given to be how much? 8 centimeter, right? Okay, now let us see what is happening in triangle ABC. Now what is our aim? Our aim is to find MN, right? So to find MN we will find MO and ON. Alright, so in this triangle, that is triangle ABC, we see that this ON will be half of AB, isn't it? So since ON is half of AB, so that's why my ON turns out to be half of 11, because AB is how much? AB is 11, so that's why instead of AB I have written 11, and half of 11 will be how much? It will be 5.5. Alright, so similarly let us see this triangle ACD. So similarly this ON, alright, this OM will be half of DC. Okay, so using midpoint theorem, so OM will be half of DC, so that's why OM is half of CD, which is how much is CD? CD is given to be 8 centimeter. So half of 8 is 4. So from here to here is 4 centimeter, and from here to here is how much? It turned out to be 5.5 centimeter. So what is MN? So MN will be MO plus ON, which turns out to be how much? 9.5 centimeter. So we have seen the first question. Now let us go to the second part. So second part says we need to calculate AB. Alright, so we need to calculate AB if DC. So DC means this is given to be 20 centimeter and MN is given to be 27 centimeter. Alright, okay, so these two are given. So let us see again triangle ACD. So again in triangle ACD we know that this OM will be half of DC, right? So that's why DC is given to how much? 20. So OM turns out to be half of 20, which is 10 centimeter. Alright, so therefore ON, now see, MN is given to be how much? 27, right? So MN is given to be 27, and we just now found OM, which is how much? Which turned out to be 10 centimeter. Alright, so from here to here is 27, and from here to here is 10. So what is this length? This length is obviously going to be how much? 17, because 17 plus 10 gives me total 27. So that's why ON will be 27 minus 10, which is 17. Alright, now again in this triangle I can say that this AB is double of ON, right? So that's why AB is double of ON, which is how much is ON? ON is 17, so double of 17 is how much? 34. So that's why AB will be equals to how much? 34 centimeter. Alright, now the third part is also similar. I'm not going to explain here, so you can have a look at it. Alright, so this number 3 is similar to question number 2. Alright, so you may pause the video to note down. Okay, let's have a look at the last question for the day, question number 6. So question says the diagonals of a quadrilateral intersect at right angles. Alright, so prove that the figure obtained by joining the midpoints of the adjacent sides of the quadrilateral is a rectangle. So this kind of question also we have already seen. So let us see what is happening here. So ABCD is a quadrilateral, and the diagonals, that is AC and BD, intersects at right angle. That means all this angle, this angle, this angle, this angle, and this angle, all of them are intersecting at 90 degree. Okay, now we need to prove that we need to join again the midpoints of each side. Alright, so the midpoint of AB is taken to be P, the midpoint of BC is taken to be Q, midpoint of CD is taken to be R, and midpoint of DA or AD is taken to be S. Alright, so if you join these midpoints, you will see this diagram, right? So we need to prove that this is nothing but a rectangle. Alright, so in a rectangle, what happens is the opposite pairs of lines are parallel and equal to each other, and with that we have each corner angle to be 90 degree. Alright, so that's what we need to prove out here. Now let us see triangle ABC and ACD. Oh, sorry, ADC. So let us see where is ABC. So ABC means this triangle, right? So in this triangle we have P and Q are the midpoints, so that's why I can say PQ, line segment PQ, will be parallel to AC, right? So PQ will be parallel to AC, and not only that, but AC will be double of PQ. So that's what is written here. So AC is double of PQ and PQ is parallel to AC. So let me call this as equation 1. Okay, now in another triangle, that is ADC. So where is ADC? Let us see. So ADC means we have to have a look at this triangle. Now again in this triangle we have SR will be parallel to AC, right? So SR or RS is parallel to AC, and on top of that we have AC will be double of SR, right? So AC will be double of SR. So if I combine these two, right, so if I combine these two, I can say that SR and PQ, they will be parallel, because if this is parallel to this and if this is parallel to this, then this means that this SR and PQ both are parallel. Alright, and not only that, if this line AC is double to this and this, that means this line and this line, they must be equal. That is PQ is equals to RS. Alright, now similarly you can do the same with this triangle, that is BCD and BAD. Alright, so you do the same, you'll arrive at the conclusion that this side, that is SP, is parallel to RQ, and not only parallel but this SP will be equals to RQ as well. In the same way you can try by yourself. Alright, so here what I see is the opposite pairs of lines, this line and this line, are parallel, and similarly this and this are parallel. That means this is a parallelogram. Alright, so this is a parallelogram because all opposite sides are parallel here. But we are not done still, because they are asking that this has to be a rectangle, and we know that rectangle is also a special kind of parallelogram, but only difference here is each corner angle will be 90 degree out here. Alright, so one more thing it is said in this question is that the diagonals intersect at 90 degree. Alright, so each angle is 90 degree out here. So we know that PQ is parallel to AC. So let us see where is PQ. So PQ is parallel to AC, right? So PQ is parallel to AC. So if this happens, then AOD, so let us see where is AOD. So AOD means this angle, right? And this angle will be equal to PXO. So let us see where is PXO. So PXO. Now if you see here carefully, AC and PQ are parallel, so that's why BD acts like your transversal. So if BD is your transversal, then this angle and this angle, they are called corresponding angle, and they are always equal, right? So that's what is written out here. Alright, and we already know that this is 90 degree, so that's why this is again 90 degree. Alright, okay, now again we have BD is parallel to RQ, right? So BD is parallel to RQ. BD is parallel to RQ means, let us see where is BD. So we have BD, right, is parallel to RQ, right? Now if this happens, then this line PQ is acting like a transversal. See here carefully, this line and this line, they are parallel, and this PQ is acting like a transversal because it is cutting both the parallel lines, that is this and this. Now again here also this angle and this angle, they are called corresponding angle and they will be equal. And how much is this? Just now we proved that this is 90 degree, right? So if this is 90, this is also 90, right? So that's why it is written PXO. So PXO means this angle will be equals to RQX, which is this one. So both of them will be equal and they will be equal to 90 degree because this is already 90 degree because they are corresponding angle. Now in the same way, see, I showed just now that one of the corner angle is 90 degree. All right, in the same way, all right, in the same way we can show that this is also 90, this is also 90, this is also 90. All right, so that's why if each corner angle is 90 degree, then the parallelogram must be a rectangle. So that's why I can say PQRS is a rectangle. Alright, so hence we have proved this particular result out here. Alright, so you may pause the video to note down. Thank you very much.